All right, this is section 6.2, example 3. Basically, they've given us a system of equations. You'll notice that instead of using x, y, z, they're using x1, x2, x3. Don't let that scare you, it's the same. And then basically the instructions were write as a matrix equation. Notice they used the big letter A, so that's one of the matrices, times x, which is basically your unknown matrix, equals B. Then use Gauss-Jordan elimination. So remember, Gauss-Jordan elimination is the one where you have to get it in reduced row echelon form. And what that means is it should have all zeros and ones. Row echelon form. And you're going to use Gauss-Jordan elimination on the augmented matrix. So basically, what you're going to do is start out writing A times X equals B. So what you want to do for A is you want to use all of your coefficients. So in this case, I've got a matrix here. This is my A. I'm going to have -1, 1, and -2. And then -2, 3, -4, 3, -4, and 7. And basically what you're doing is you're multiplying that times x1, x2, x3, and it gives you your B, which is going to be your constants. Okay, so this is writing it in the format of AX plus B. Or I'm sorry, not plus B, equals B. Okay. All right, so then you're going to write the augmented matrix, which I'm just going to write it off to the side here, that what that means is they want you to use just A, and then we have our ... before the B. So this is the same augmented matrix we were making in section 6.1. We're just going to have all these coefficients and then ... this one. Okay, so ... here's what it equals, 2, 5, and -1. Okay, then what you need to do is you need to use row operations to get reduced row echelon form. Okay. Okay, so basically we need to do this kind of the same way we've been doing whenever we were doing Gauss-Jordan elimination. So in this case, I need to get the leading coefficient to be 1. So I'm just going to multiply the whole first row by -1. And I'm going to get +1, -1, +2, -2. The other rows stay the same. All right, now I want to eliminate the -2. So in this case, I'm going to do row 1 times 2. 2 times row 1 plus row 2. And so I'm going to have 2, -2, +4, -4. And then down here, I'm just going to rewrite this one. Add them together. 0, 1, 0, 1. All right, so now write your new matrix. You have 1, -1, 2, -2. The new row 2 is going to be 0, 1, 0, 1, 3, negative 4, 7, negative 1. Okay. Now I need to make sure this is a 1. Well, it is, so that's good. Now I need to get rid of 3, so I'm going to do negative 3 times row 1 plus row 3. So negative 3 times this row will give me negative 3, positive 3, negative 6, positive 6. And then I add it to this one. 0, negative 1, positive 1. This is going to be what, 5? All right, rewrite it. This is my new row 3. All right, this I need to get rid of, so I'm realizing these will just cancel if I add them together. So that's what I'm going to do. I'm going to do row 2 plus row 3. So go ahead and write that off to the side. So 0, 0, 1, 6. So first row stays the same. Second row stays the same. Third row. Okay. Now this is row echelon form. Sorry, I just realized you couldn't see that. Okay, row echelon, but I want reduced row echelon. So basically it's great that I have these zeros, it's great that I have these ones. I need to get everything else to be 0, okay? So in this case, in order to get rid of this one, I'm going to do row 1 and row 2 together. So I'm going to do row 2 and row 1. Because I see here this is negative 1, so I need to add 1, and then this will be 0. So usually I do that off to the side, so I'll just put it down here. I have 1, negative 1, 2, negative 2, and I'm adding row 2 to that, 0, 1, 0, 1. And I get 1, 0, 2, 1. Negative 1, sorry. Okay, so that's my new row 1. So let's go ahead and rewrite that. So instead of this row 1, I now have this one. Notice I kept my 1 at the front. You definitely need to do that. And then row 2. And then row 3. That looked a little bit like a 1, sorry. All right, so notice I've got all these 0, 0, 0. This 2 is a problem. I need to get rid of this 2. So what I'm going to do is I'm going to do this row 3 times negative 2. So negative 2 times row 3 plus row 1. Okay, so if I do negative 2 times row 3, I'm going to have 0, 0, negative 2, negative 12. Plus row 1, I'm going to have 1, 0, 2, negative 1. Add them together. These cancel. All right, so that's my new row 1. Okay, this is reduced row echelon form. Notice everything on the left is 0, 0, 0 with the ones down the middle. And so basically, once you have that, you know your X, Y, and Z. So in the, excuse me, sorry, in this case, they're not using X, Y, and Z. They're using X1, X2, X3. So basically, this if you want to look at it, before we said we had our A and our B. Now you'll notice this one is the identity matrix and this one is the X. So what that means is that X equals these things. So basically you're going to have your X, which is the matrix X1, X2, X3, equaling negative 13, 1, and 6. And really, sort of, this is the notation, but an easier way to think about it clearly is that X1, the first one, equals negative 13, X2, the second one, equals 1, and then X3 equals 6. So if you were writing this as an ordered triple, you would just write them in order negative 13, and then 1 and 6. As always, plug it back into the original just to make sure that you've done it properly.